Okay, so let's have a look at how we can actually make our path random, because right now we just saw demonstrate that we can spawn tiles straight and we can spawn them to the side. Um, we need to change one little thing to make it easier for us to do it, make random stuff. If we go into our script, you'll see that we have left tile and a top tile prefab, and we would like to be able to select them at random. And the easiest way to do that is to put them into an array so that we can select something from within that array with a random number. Because basically we can make a public game object array, and you make an array by writing the data type you want to create an array of, and after that you make these square brackets to indicate that you want to make an array. And I'm just going to call this tile prefabs. And this array needs to be instantiated before we can use it. So in start, I'm just going to say tile prefabs equals new game object. And actually, we don't need to do that because we are in Unity. I have been coding too much in clean C#, because we're just going to make this public array, and then we're going to instantiate it from the inspector, of course. So if we click on the tile manager now, you'll see that we have this tile prefab, and we can set the size to 2. There we go. So now that we have the size of 2, we can actually start placing our prefabs in it. So we have left tile and we have our top tile, and we need to take the left tile and put in element 0, and the top tile and put it in element 1, which means that we don't need these two up here anymore. So we can jump back into our script and delete these two. And now it's going to complain because we don't have it, of course. So the point is that inside our tile array we have these indexes. As you can see, element 0 is left tile and element 1 is the top tile. And we can access these tiles through our code, through the indexer on the array. So if I want the top tile, I can say tile prefabs 0 to access the top tile because it's at element 0. As you can see down here, if I want to access the top tile, or was it left tile? Sorry, yeah, top tile is 1 and left tile is 0. So if I want to spawn the left tile in my game, I can actually go to in here and say tile prefabs 0. And if I save this and go back into Unity and play my game, you'll see that it spawns all my left tiles, and you can see it's wrong right now because we're using the wrong pivot point, as I mentioned earlier. So we need to say 0 here instead, of course. See? Boom. Now we just spawned all these to the left. So if I go back in here and say I want to spawn my top tiles, change this index here, and I play my game again, if I remember to save, then you can see it spawns the straight tiles instead, top tiles. Okay, so now we have a array we can actually use for picking a random tile in. To pick a random tile, I can use a random number generation. So I'm gonna make an integer, and I'm gonna call this random index, I think. And this random index is gonna be equal to random dot range, and I'm gonna say between 0 and 2. Okay, so why am I picking 0 and 2 when there's only 2 index here? So inside this one we have index 0 and we have 1, and I'm picking 2. The reason that I picked 2 is because the upper bound of the index is not included. So this line of code is going to generate a number between 0 and 1. If I would do this, I would get returned 0 at all times because this number is not included in the range apparently. I found that out by testing. It's not written in their documentation anywhere, but it looks, or maybe it's written in their documentation on the homepage. But right now I'm generating a random number between 0 and 1. And this is going to be my random index. And the smart thing here is that, well, my tile prefab 1 also needs the get child 1. So I can use this random number to get the correct tile by taking random number index here, placing it here and here. So if it rolls 1, well, then we take prefab 1 and we take child 1 because that's where we need to place it. If it rolls 0, well, then we take prefab 0 and child 0. So let's give it a go and see what happens if this random thing works, else we need to fix it. Yes, and as you can see, we just generated a random path. Go straight, left, and then straight again. And if we run our game again, it should look a little different. As you can see now, it goes all the way to the left instead. There we go. So now we can actually generate random paths. But we need to add some functionality. As you can see in the game, the level is infinite, and these tiles are falling down whenever whenever we run through them. So let's try to make an infinite level, and then we can start removing the tiles after in another video. So to create an infinite level, we need to know when we need to spawn some more stuff, because we can't make an infinite level when we just start our game. It's gonna take forever because it's infinite, and we would like to have maybe 100 tiles when we start our game. Let's just order 30 or something, and then when we're running through our game and our tiles disappear, well, then we want to add more tiles so that our level continues forever until the player dies. So to do this, we can use a collision box actually. So if we take our left tile first and go close to that, we can add a collision box to it. So we already have some collision box and stuff on the tile itself, but we're using that collision box to avoid falling through it. As you can see here, our player lands on the tiles, and when he runs out here, he doesn't fall through the ground here, because that's what we're using that collision box for. So I would like to add another collision box to the left tile, to the main tile here. That's our pivot point. So click add component on it, and then write box, and then we need a box collider, and we're using the normal box collider because that this is 3D models. Actually, we are rendering in 2D. So this needs to be edited a little. You can take the edge, if you click edge editor, you can grab these and make them maybe a little larger than this, because we're also going to use this later for dyeing or something. So yeah, maybe just make them a little larger than the actual brick itself. If I could stop misclicking. Apparently I can't. There we go. So as you can see right now, the collider is sitting down here, and we're not interested in that. So we're gonna take the center here and drag it upwards, and just to make sure that we hit it, we're gonna take the size Y, just make it a little bigger here. There we go. So now we have a box collider that fits. We can actually right click on this box collider, and we can click copy component, and we can take our left tile here and save it in our prefab by dragging it down to our left tile prefab, then delete it from the scene. And then we can take our top tile, and we can actually right click, let's just see add component first, sorry, and we can right click on this, and then we can paste component values. And as you can see, it already pasted all the values from before, the size and everything, but the position is not right at the moment. So we can take this center here, move it a little to the right, and see and move it up a little. There we go. So now we should have a box collider that actually also fills up the area around where our player enters, so that we can test when our player comes running here, and he goes through the collision box here, then we should spawn some more tiles. So Let's save the top tile by dragging it down into the prefab here again. So now we need to add a new script that should be aware of whenever the player enters the tile. We could either go to the player's script and then check if we enter a tile and spawn something new, but I would like the tile to be boss of or master of whenever we want to spawn a new tile. So we're gonna go to our scripts and we're gonna right click on it, create, and it's a sharp script, and I'm just gonna call this script tile script. Okay, so this script should go on our tiles basically. So we're gonna go to our prefab here, click on lift tile, add component, and we're gonna write tile script, add that there, and we're gonna click on the top tile as well, click add component, and click on the tile script to add both of them. So the script is already on it. Then we click on our script and we're gonna double click on our tile script to open it. Yes. So we need to figure out whenever a player enters a tile, and we can do that by using the function void onTriggerExit. And onTriggerExit is called whenever a trigger exits the collision box, or like something exits the trigger. That's what it's called. So I can say collider other, because the player is a trigger, so it isn't a trigger, so it's just when something exits the trigger. So whenever something, say we have our object here, when something goes through here and exits here, well, then we can start spawning a new tile. But let's just check if this onTriggerExit works first. So we can say if other.tag equals player, then we want to say debug.log spawn tile. Let's just save this once, and then we need to go back into our game and we need to check that our collision is trigger. As you can see right now, it's not set as trigger here, and it needs to be a trigger because we are calling onTriggerExit, which only works if the collider itself is a trigger. So we're gonna go to left tile, make sure it's a trigger, top tile, and make sure it's a trigger. And this has already affected our current tile because it's a product of one of these. So let's see if we run our game and we run through one of these, see if anything happens. Nothing happened here. And the reason that is because we clicked our player. As you can see, it has no tag on it. I just forgot to put it. As you can see, I say if other.tag equals player, and right now it's untagged, so I need to tag it as a player. And let's give it a go again, see if something happens now. Spawn tile, there you can see. Let's see, spawn tile got called 11 times here. So spawn tile definitely works whenever we enter something or exit something, it is, then our spawn tile is called. So now we can use the functionality to spawn a tile instead of just writing something in our debug. So we need to make the spawn tile function available for our tile here, tile script. So this tile script needs to be able to access the function called spawn tile here. And to do that, we need to make this tile manager into a singleton. And a singleton is a design pattern that makes it possible for us to access it, this tile manager everywhere in our game or in our script. And it also makes sure that there's only one tile manager in our game at any point. So the part about having one tile manager is not 100% correct in Unity, because in Unity you have to work a little differently because of different components and stuff. So nothing is stopping you for adding another tile manager. But normally in C# program you could use this to make sure that there would only be one instance of this. But right now we just need to use the singleton instance to make sure that we can access our tile manager from our tile script, and make sure that we call this spawn tile function whenever our player enters or exits one of the tiles. So we need to make a public static actually we need to make private static tile manager instance. So why is something static? Well, when something is static, we can actually access it on the class level here, which means that I can write tile manager dot and then access it. So if we try to make this public, for example, and we make it non-static. So if we make it non-static and go to our tile script here, and I write tile manager dot, well, then I can't access it from in here because it's not static. But the second that I go back to my tile manager and make this static and save, then you'll see that I can say tile manager dot instance, and I can access it here because it's static. So when something is static, there's only one instance of it, and it's on the class level, so that it affects all instances of this tile manager. So in general, it's bad practice to just make something public like this in C# programming. Usually in Unity, of course, you can do this public game object, but usually you will make something called properties to access this. So I'm gonna do it the normal way, try to make a singleton so it looks more correct. So I'm gonna write private here first, and then I'm gonna make a property. So if you have Visual Studio, you can right click here and say refactor and encapsulate field and click OK. If you don't have Visual Studio, you can just write this code by yourself if you're using MonoDeveloper or a Xamarin or something. So the set function, we don't need that. And then we can make an if statement that said if our instance, this instance up here, if that one is null, so if it doesn't exist yet, if we haven't accessed it yet, well, then we're gonna say instance equals game object find object of type tile manager. So what I just did was that I accessed or I made sure that I find the tile manager here, and I make a reference to it through this instance here so that I can access it other places. So this instance here is referring to itself, so that I from my tile script can write tile manager dot instance to access all the functionality in here, and then I'm going to return the instance here. I'm going to save, which means that I can go into my tile script here and say tile manager dot instance dot, and then I can access everything I have in there. So I can access spawn tile, and the reason that I can access spawn tile is because it is public here, which you probably already guessed. So it's public and I can access it here. So we can remove this debug.log, and let's save and go back into our game. So from the get-go we have 10 tiles, whatever we had, and now we should be able to keep spawning tiles. As you can see here, the level is generating in chunks here because we keep spawning them as we go through them here. So now we have an endless random level. So normally I guess we would add some more tiles from the beginning so that we can't see our level generating like this. And another thing you need to take into account is that when you instantiate an object, it takes a lot of CPU power, which means that we are instantiating a tile every time we run over a tile, so this might lag on a mobile device. So we're going to change some functionality later so that we create all our tiles from the beginning and then we just recycle them, because usually in the ZigZag game, whenever you run over a tile, it should fall to the ground. You see here, when we do like this, it should fall to the ground, and then we're simply going to take it and reuse it later so that we don't have to instantiate and destroy, because normally we would make them fall to the ground, all the tiles, and when they fall to the ground, well, then we would destroy them and we would keep making more. So destroying takes up CPU power, and creating tiles all the time also takes CPU power. So instead of that, we're just going to create maybe 100 tiles, and then we're going to reuse them by moving them around. So when one of them falls to the ground, we're just going to put it at the end of the row instead. So just as a start, we can say that inside our tile manager, we would like to create maybe 50 tiles from the get-go when we start our game. So if we do that, then it takes a little while, and then we have 50 tiles. So we can't see our level being generated now, as you can see here. We just have our random level like this. Okay. So I think this is it for this video. In the next video we'll try to recycle our tiles and make them fall to the ground, so whenever we run over them, actually we'll do that first, so we run over here, these tiles should start falling as it does in the real game.